So next, I will introduce the composite materials. Composite is composed of two or more individual materials that come from the category previously discussed: metal, ceramics, and polymers. Composite has two materials mixed together, metal mixed together, ceramic, and polymers. Design goal of the composite to achieve the combination of the properties that is not displayed by any single material. Our goal of the design of composite material created a new materials system. That property cannot be realized by using any single material. And also to incorporate to the best characteristics of each component materials. A large number of the composite types are represented by the different combination of the metal and ceramic polymer. Furthermore, some naturally occurring materials are composite, for example, wood and bone. Wood and bone can be regarded as a composite material. However, most of those we considered in our discussion are synthetic composite. So in my lecture also, I do not explain the wood and the bone as a composite materials. I do not. So I explain the composite material, synthetic composite materials, or human-made materials. We can make a composite material. Wood and bone, we cannot make wood and bone. Naturally, we can get the wood and bone. But my composite materials, definition of the composite materials in my lecture is human-made composite materials. Among the human composite materials, there are several types of the composite material system. One is GFRP. This is glass fiber reinforced plastics. One of the most common and familiar composite is fiberglass, in which small glass fiber are embedded within the polymeric materials, normally epoxy polyester. The glass fiber is relatively stiff. Glass fiber is a ceramic material system, and the ceramic has a higher stiffness than the polymers, higher strength polymer. So that relative higher stiffness and strong materials embedded in the polymer material. And the GFRP has a low density. As I explained the density. So the metal, higher, lower, ceramic, lower is ceramic, and the polymer is more lower than the ceramic, and composite is also low density. Next is CFRP. That is carbon fiber reinforced plastic. Another technologically important material is carbon fiber reinforced polymer, CFRP, composite. Carbon fiber that are embedded within the polymer, as well as GFRP. These materials are stiffer and strong than the glass fiber reinforced materials. CFRP has a higher stiffness, higher strength than the glass fiber, because carbon fiber has a higher stiffness, higher strength than the glass fiber. but that is expensive. CFRP composites are used in some aircraft, aerospace application, as well as high-tech sports equipment. Sports equipment is bicycle, golf clubs, tennis racket, ski or snowboard, and recently the automobile bumpers. And Boeing aircraft 787 has a primarily made from such a CFRP composite. Next is advanced materials. Materials utilized in a high technology application and sometimes termed of the advanced materials in the high technology application field. So we say the material can be used in such a field we call the advanced material. By high technology, we mean the device or a product that operate or function using the relatively intricate, sophisticated principle, including the electronic aircraft and military rocketry. These advanced materials, typically traditional material whose properties has been enhanced and also newly developed high-performance materials. So the materials, metal, ceramic, polymer, and mixed together composite materials, and next is advanced materials. Furthermore, they may be all material types: metal, ceramics, polymers, and normally expensive. Advanced materials include semiconductors, biomaterials, smart materials, and nano-engineered materials. The properties and application of the integrated circuit, magnetic information storage, liquid crystal display, and fiber optical, and also these are good examples. So the advanced material is not a metal, is not a ceramic, is not a polymer. So all of the material type can be used in the advanced material fields, but a little bit expensive. And please remember these keywords: semiconductors, biomaterials, smart materials, and nanomaterials. So semiconductors, biomaterials, smart materials, nanomaterials. These are materials in the field of the advanced materials. Semiconductors and biomaterials and smart materials and nanomaterials. So please check these 4 material systems. But particularly in the nano material, dimension is the structure is very, very small. So very, very small material, even if we use ceramic materials, but that particle is become very, 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 very small. So that material system can make a new performance. So that is a easy understand of the nanomaterial system. Okay, these are explanation of the nanomaterial. Okay. So the carbon nanotube, graphene, these are very, very attractive keywords in recent years. Nanocarbons carbon nanotube, graphene. So these are material systems from the nano engineers. And the modern material needs. What do we need? Material. What kind of the performance or something are required to material? One is the nuclear energy. In the application, nuclear energy material which can be used in the nuclear energy. What are they? Next is energy transportation. So reducing the weight of the transportation vehicle or car, as well as increasing the engine operating temperature, will enhance the fuel efficiency. New high strength, low density structure materials remain to be developed, as well as materials that have high temperature capability for use engine components. So the energy transportation, economic source of the energy, and solar power to ensure the viable technology, materials that are highly efficient in this conversion process, yet less costly, must be developed. Lower cost conversion process in the solar power. What kind of material is effective or not? Hydrogen fuel cell. That is also the very important keyword in our recent society and our future society. Pollution control technique. That is very important from the SDGs. Many materials that were used in the delivered from the resource are non-renewable, that is not capable of being regenerated, including the most polymers, for which prime raw material is oil and some metals. These non-renewable resources are gradually become depleted, which necessity discovery the additional reserves and develop new materials having comparable properties which less adverse environment impact, and increase recycling effort of the development new recycling technology. These 1, 2, 3 is very important message from the society, and we send these messages to the material science and engineering to make a new material system, to develop the new processing technique, and including the processing technique, new material system, recycling is important keyword. So the economics is important, lower price, but environmental impact is also very important. The role of the material scientists and the engineering plays relative to these as well as other environmental social issues. So as I mentioned before, what material science test is doing. So the selection of the materials, and when we meet a failure, we propose a new design system and a new material system, new processing system. Material scientist, engineer, material science and engineers propose this one. But plus, material science and engineers should understand the cost, not only cost, and environmental. And we think our society. So that is the role of the material scientist. Summary of the 6 different